A Nest Learning Thermostat costs $249. After 6 months, it still needs a server in Virginia to decide when to turn on your heat. We assume that a smart thermostat learns your schedule the way a programmable one did, by storing patterns locally. In reality, it sends your behavior to a data center, calculates there, and streams back instructions. The device you bought isn't making decisions, it's displaying them. The architecture is explicit. When you adjust the temperature, the Nest sends your request to Google's servers. Those servers retrieve your historical data, run predictive models against current weather and occupancy patterns, calculate the optimal schedule, then transmit a command back to the physical unit. The round trip takes between 200 and 600 milliseconds. If your internet is down, the device has no algorithm to fall back on. It reverts to manual-only mode, like a thermostat from 1987. This wasn't a technical limitation. The Nest contains 512 megabytes of RAM and an ARM processor capable of running machine learning inference locally. Similar processors power smartphones that recognize faces offline. Storing 12 months of temperature data requires less than 50 megabytes. The capacity exists. The decision was to not use it. Why build it this way? 3 reasons. First, cloud processing allows continuous algorithm updates without hardware changes. Your thermostat's behavior improves as the model improves, but you never own the model. Second, centralizing computation reduces manufacturing cost. Adding the necessary local processing capacity and storage would increase per unit cost by $18 to $28, roughly 7 to 11% of retail price. Third, keeping the intelligence remote creates ongoing dependency. The product requires infrastructure the company controls, and can discontinue. The trade-off emerges slowly. You pay $249 for a device that includes sensors, a display, and network connectivity, but not the logic that makes it smart. That logic lives in a data center, accessed via subscription to a service you didn't explicitly sign up for because it was bundled into the purchase. The thermostat is less a product than a terminal. Hardware that only functions as long as someone else's servers do. Older programmable thermostats stored 7-day schedules in 2 kilobytes of non-volatile memory. They cost $40 to $80 and worked for 15 years without external dependencies. The Nest is more sophisticated. It adapts, learns, optimizes, but that sophistication is rented, not owned. When Alphabet decides the Nest line is no longer profitable, or when your model is declared legacy, the servers stop answering. The device on your wall becomes a very expensive manual switch. This pattern repeats across connected devices. Ring doorbells that can't process motion detection locally. Smart locks that require cloud authentication to verify your own fingerprint. Security cameras that upload video for analysis instead of analyzing on device. Each one could be built to function independently. Processors are cheap, storage is cheap, algorithms are well understood. But independence is expensive in a different way. It prevents ongoing data collection. It eliminates per unit recurring revenue. It makes the product genuinely yours. The invisible decision is this. Smart no longer means capable of autonomous operation. It means connected to someone else's capability. The thermostat learns, but only through infrastructure you don't own and can't inspect. Your preferences are analyzed, but not where you can see or modify the process. The device adapts, but only as long as a distant server agrees to keep adapting it. You bought the thermostat because it promised to be intelligent. What you received was an interface to someone else's intelligence. An intelligence that can be withdrawn, repriced, or discontinued whenever the terms change. The $249 covered the hardware. The ongoing dependency was the part that didn't appear on the price tag. Once you see that decision, you start noticing it everywhere.